Good morning, everyone, and good afternoon, and good evening, wherever you are, and welcome to today's TU Automotive webcast. The topic for our webinar today is the MQTT Key to Scalable, Reliable, Connected Car Platforms, sponsored by HiveMQ. I'm Steve Bell with TU Automotive. I am Principal Analyst there, and to begin, let me explain some of the mechanisms by which you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. And if you need assistance solving common issues, please tick or click on the yellow help icon below the slides. Additionally, we welcome your questions during today's event. We will answer as many of the questions as possible during the Q&A session that will follow the main presentation. But please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the Submit button. And just to make everybody aware, today's session is being recorded and you will be notified by email when the archive is available. So as I said, today's webinar is sponsored by HiveMQ, and it's part of a webinar series that we look to educate our audience in where the technology trends are going, and in particular, how to build a reliable connected car platform. I am joined today by Christian Gotz, who is the co-founder and CEO of HiveMQ. Christian has been involved in enterprise software development since 2008 and with IoT since 2011. He's a thought leader and he's spoken at numerous industry conferences and written articles about IoT architecture. When he isn't working or growing at HiveMQ, he's reading, running, spending time in beautiful Bavaria in Germany. So welcome, Christian. Today's agenda, sorry, thanks, Christian. Today's agenda is going to have a brief introduction from myself, and then we'll go straight into the HiveMQ presentation, and we will probably have somewhere in the region of about 15 minutes at the back end of the session. So I encourage you to send in your questions, and we will certainly engage in a lively discussion around them at the back end. Throughout the presentation, we will also have several poll questions, and I encourage you to participate since this makes it very much more interactive, and we get a feel for you as an audience, your level of knowledge, the issues maybe that you're facing, and that helps us address them throughout the presentation. So without further ado, connectivity is one of those things that's been a part of the automotive industry now for over 20 years, since the first analog and digital devices were included in the units. And increasingly, it's being utilized for safety and for advanced crash reporting. As 4G and 5G begin to spread across the globe and take over from the 2G, 3G networks and modems incorporated into the vehicles, enhanced capabilities are being included, particularly related to infotainment, including Wi-Fi hotspots, but also the ability to deliver with voice assistance and mapping, better directions, better navigation, better engagement, and obviously better safety aspects. It also facilitates increased driver monitoring, which can also be both a mechanism for reduced costs in terms of insurance, but it can also be a safety advantage in terms of monitoring the driver's sleepiness and being able to use the car as a mechanism for waking or helping the driver realize that it's time for a break. Also, you're starting to see the emergence of the vehicle-to-vehicle and vehicle-to-everything infrastructures, whether that's based on digital short-range communications or more likely LTE and 5G technologies over the coming years. It will increase the safety, enhance the advanced driver assistance units, and also facilitate better autonomous vehicles going forward. You're also seeing the emergence of digital twins, which linked to telematics data enables the manufacturer to really keep track of the vehicle throughout its life, to provide security, to provide safety, to provide updates. And one of the key aspects of that, obviously, is that the messaging and the monitoring on the program or on the vehicle needs to be reliable. And what is interesting is that the automotive industry is not a silo. The automotive industry is a huge industry, but it's moving forward, as are other industries, and technologies have been moving forward as well in adjacent markets and adjacent industries. And one of the interesting aspects is that IoT, particularly related to telematics, over the last 20 years, the introduction of a concept called message query telemetry transport, which is now an OASIS and ISO standard, which was utilized to help IoT systems ensure messages went through reliably, and the protocols that were developed for that are, as you will hear in the upcoming 30 to 40 minutes, being applied in the automotive industry with increasing impact to enhance the ability to truly monitor and also enhance the experiences of the vehicle. So with that, I will hand over to Christian. Christian, please take it away.
Thanks so much, Steve, for this introduction, and I'm happy to be here today with you guys to do this webinar and discuss more about how exactly all these, like the car use case you just outlined, we kind of help in all of these OEMs and all the automotive suppliers and people in the industry to implement and to enable them to kind of build new solutions that enable the future automotive technologies. Before we start into the content, a quick background on myself. So I'm the CEO and co-founder of HiveMQ. We are an 88-year-old company based out of Munich, currently 32 employees, and we have already 130 plus customers with production IoT applications. Also, due to the fast growth, we have been rewarded with certain awards like the Deloitte Fast 50 Award, or also one of 10 most innovative IoT companies to watch from 2018. And we have been one of the growth champions 2020 from a German business magazine called Focus. From a, let's say, from the HiveMQ perspective, we have customers not only in the automotive, which we will talk mostly about today. We also have customers that we help building new digital products in general, which are, for example, also telecommunications like Liberty Global or T-Systems, but also from transportation, manufacturing, and also a big part of it is automotive. And not only building new digital products or improving the customer experience, but also an important part is creating more efficient operations and insights from IoT devices and applications. So, and of course, as today's topic is based on automotive, we provide we help to build automotive companies connected car platforms, car sharing services, but also connected car services as well. So we kind of have a very broad spectrum that we help people connect to and work with in the automotive industry. But more on this in the course of the webinar. Before that, we want to have a quick poll and then hand it over to you, Steve.
Thanks very much, Christian. What we'd like to know is what type of company you work for, particularly related to the automotive industry. Are you an OEM, an automotive third-party platform, an automotive supplier, or are you related to some other industry? Having a quick look at the audience, Christian, I think we've got quite a cross-section, so it'll be interesting to see what the results are in a few moments, but it's certainly sort of looking very interesting at this point of time. So I'll give the audience just a few more seconds, and then we'll see what the industry participation is.
Yeah, I'm also excited to see.
Yeah, let's have a look and see. Okay. So 18% OEMs, 23% automotive third party, and 18% for suppliers, and 39% other. So it's interesting. With that, Christian, I'll let you go on.
Yeah. Yeah, thanks. So thanks everyone for taking the poll. So it's interesting to see you have a mixture of people here, and it's also what we see in the industry, because kind of all different parties are concerning themselves with the industry trends about connecting cars. And the interesting, so I put just out one statistic I think is very shows also the future of connected cars. So from 2018 to 2022, 125 million connected cars will be shipped worldwide, which is a pretty impressive number when looking backward. That we have, of course, we have connected cars for quite some time, but in the age of smartphones and want to have everything instant, like WhatsApp, having push notifications and so on, we see, especially with the automotive customers we have, that people are expecting a very high standard for their connected cars. But also, of course, the OEMs we talk to, they want to make sure that the brand experience is very good and awesome for all the people using it, because using apps for example, opening or closing cars becomes more and more the connection towards the end users, who like the car drivers and everybody who uses the car, just to show them how innovative and what's already possible with new technology. And this is also something where we often see problems when, especially using old technologies. So one example is remotely unlocking a door, like a car door from the mobile phone. And we kind of saw it with old technologies. You kind of send a message to the cloud, to the car backend. Then, if it's old technology, sometimes it has to go through an SMS wake up to wake up the car. Then there needs to be a HTTP request sent in order to fetch the new information from the server. And then you can even get the unlock command to the car. And we have seen cases which to customers we talked to, this process could actually took up to 30 seconds. It means that if you're standing in front of your car, you want to open it with your mobile phone, but it takes up to 30 seconds to open. And this is something which is really far too slow and unreliable for people to use, because standing, if you've ever done this, like waiting 30 seconds for something or in front of something, is really annoying. And people from the WhatsApp generation, they expect to have this immediately and not like in 30 seconds. And this is just one thing here which we identified that is the current challenge, especially when you have not only one car to open, but I think from Volkswagen, they said they want to have 10 million new cars connected every year. And even there are bigger brands already also out there, and also smaller brands. But there is a lot of vehicles getting connected, and the 125 million overall also shows there's a big number. There's a huge challenge into connecting all these and providing every single user the same experience. And so this is only one thing I want to outline more, but there are 5 other challenges we stumble across very often. So the first one is unreliable networks and network latency. That means often when you drive around, you have unreliable cellular networks. Hopefully this will get better with the 5G coverage and also more 4G and 3G coverage in the future. But still, there are areas which are tunnels, which are out in the countryside, where you have only small signal strengths or even no connection. So connected car use cases need to be able to deal with these kind of scenarios, and also, of course, in any way decrease latency, because this will also make it more harder for the people inside the car or using the car to kind of get the full value of the technology. As a second challenge, of course, when having more and more devices out there, the old technology was always unidirectional. So you had always one car to the server, and one, let's say, a very unidirectional connection that could not really kind of message back and forth or sending broadcasts to a lot of cars, especially, for example, when there is a accident on a road, making sure we can send the message to all the cars nearby to warn them or the navigation systems from this kind of problem or traffic jam, so they can safely navigate around it. So really broadcasting messages to large fleets has become more and more of a challenge. Also, challenge number 3 is, of course, scaling up to meet demand. So there are, I think, more things to this. So the first one is there are getting more and more cars connected every year, and we're not talking about thousands, we're talking about millions. So OEMs, which we are working with, they have the challenge that they need to be able to kind of add millions of cars every year to be available to do this on the server infrastructure, and but also handle this on the messaging back and forth layer, as well as also making sure you don't just buy a lot of expensive hardware, just to make sure you can also scale up and down on the cloud, to make sure this kind of is on a cloud native environment that kind of only uses the bandwidth and also the servers that you really need for the current demand, because everybody knows in cars there are peak times like mornings and evenings, to make sure the servers or the infrastructure only is kind of there for what is needed currently, and not kind of just idling around the whole day. Another one which we see often is then if the challenge of kind of connecting is solved and the massive cars already connected, it's about integration. So the data coming from cars is not valued nothing, is not value anything without connecting these to big data systems and to the kind of value providing systems in the cloud. So it's very important that all the telemetry information coming from the car, that needs to be put into the right data stores, like big data system, analytics system, to make sure they are appropriately used and also kind of analyzed, and then there's real value for the end user, or also, of course, for the car OEM to get some more data about how people are using it. And the last challenge, also an important one, is how to monitor and troubleshoot deployments. Because when you're talking about millions of cars, sometimes people call the hotline and say, hey, I have a problem with my car, the navigation system doesn't work anymore, or there is some strange behavior on my MMI, so what can I do? And sometimes it's very hard to get these error messages from because you have error messages from millions of cars, just to figure out which car the person is talking about. Actually, to isolating single cars and following their pattern of their data, just to make sure they can be troubleshooted, and to make sure they are you can as an automotive OEM give the car user the information he or she likes. So, and again, we have another poll about what is what is the challenge you guys also already encountered. So, hand over to you, Steve.
Okay. So you've heard the challenges. What do you think is the biggest challenge in automotive? Unreliable networks and network latency, broadcast messages to large fleets of vehicles, scaling up to meet demand, integration with existing enterprise systems, monitoring and troubleshooting deployments. I'm sure, Christian, that based on your discussions, you have a sense of which of the five is the greatest, and it'd be interesting to see whether the results surprise you or not when they come in. And I'll give it a little bit longer for people to digest. But they were interesting aspects that you were talking about in terms of the scaling elements. I think is particularly key. So
yeah,
let's see.
Yeah, scaling is always important.
Yeah, let's see what happens. Okay. Unreliable network and network latency, 42%, scaling up, 21%, integration with existing systems, 25%, and monitoring, 6%. The broadcast messages to large fleets of vehicles is quite small. What's your reaction? Is that a good cross-section of what you've been seeing, or?
So it's interesting. There's the monitoring and troubleshooting one. It comes of more importance when you're actually in production. So we have less customers thinking about this beforehand, but as soon as they are in production, they think a lot about this. So this is quite what I have expected. The 4.1% on the broadcasting is a little bit low. I would expect more here, but in general, it kind of is congruent with my expectation. The first one being the number one. And then, of course, integration is always a big topic, and then also scaling up. Scaling sometimes varies because scaling sometimes people think it's just a given, but other things is a challenge. I think it depends where people are coming from.
Cool. All right, I'll let you go on with the rest and tell them how to do it.
Cool, thanks. So as we've seen the kind of these challenges, when we look at how kind of we see that kind of new technologies are needed for solving these, because what often we see when talking to prospects or potential leads is that they are using HTTP or other technologies which we have used for web applications, like handling thousands of users on a web browser. But actually, for connected cars and also the whole IoT movement, the question is, what do we need for technology for using IoT? And also which connected car is a big part of. So I think you said it in the beginning, so MQTT is one of the key things here, and it introduces a paradigm shift, just to think differently about how we address or how the devices, the cars are communicating with the server or the backend devices. And MQTT really enables more the IoT pattern, where, for example, where you don't have anymore this kind of direct communication between the car and the backend, but you have an MQTT broker in the middle that kind of is brokering all the connections and does make sure that the scale is there, but also it decouples two parties. So that means the car can just send all the data to the MQTT broker, and the backend, the mobile phone, or whatever else devices out in the network, like a remote desk, like a lot of OEMs, we now have remote desks to just diagnose vehicles and so on. It could also be backend analytics applications and so on. They can just subscribe to messages that they are interested on. And this also, for example, allows to just sending the vehicles subscribe to certain areas they are currently moving through. They can receive events from, let's say, one particular area they are currently in, which totally reverses the pattern. This really allows more flexibility and also the way to easily address signal cards, but also to send messages to a group of vehicles. Just to sum it up, so MQTT is an ideal protocol for connected car because it's lightweight and simple. So also on the car side, simple to implement. There are implementations in all kind of programming languages available. It's publish subscribe. So you can ideally subscribe only for a small data set and don't receive all the messages for certain channels. And this goes on both directions. So the car can only subscribe to certain data sets, but also the backend. So different backends can take care of different data sets. It has persistent connections. That means it's always connected, the car with the backend. This allows instant and push notification-based messaging. And it also has quality of service levels, which makes it reliable and very easy to kind of ensure that all messages getting to the receiver. In comparison, HTTP is request response. There's a handshake necessary for each connection. There's a lot of duplicate data transfer there. So also from a bandwidth perspective, we have around 80% more data. We have done a study with an automotive OEM. It's around 80% more data when you use HTTP regarding towards MQTT because a lot of back and forth is just avoided. Also, there's no ability for bi-directional. Sometimes even SMS is used, which is totally unreliable. And there is no quality of service, no queuing of messages for lost connections and so on. The MQTT provides a lot of additional features above the foundation of being lightweight and publish subscribe to make it more easier to kind of connect cars or moving things towards the cloud, and therefore also with any kind of backend necessary. So now the interesting question is, and then handing over to Steve, is who has already used MQTT?
Indeed. It'd be interesting to see how many people have actually engaged in this. So do you already use MQTT? Simple yes or no, or plan to in the future. It is interesting. I mean, the degree to which people are familiar with the process. I mean, is that sort of a challenge from your side, Christian, that about familiarity with MQTT in this space?
So nowadays, I would expect a lot of people have already heard about MQTT. Of course, it always takes time to kind of implement it and to bring it into production. But for now, the MQTT is around since a long time. It has been especially publicly been getting traction in 2012. I would expect a lot of people already know it, but of course, it always depends on if it's already used or not.
Right. Well, let's have a look and see. For some reason it's going backwards. Sorry. There we go. Sorry about that. Try submitting again, please. Now you should be able to see the response. I'll give it a few more minutes. For some reason, they were back to front, so I apologize for that. We'll have to go back and have a look. All right. Okay. Poll results. Let's have a look now. So 51% have used it. 33% no, and 15% plan to in the future.
Yeah, kind of. It's kind of what I would have expected. So almost 75% are either using it or planning to use it in the future. So that's cool.
Let's go on.
Okay.
Sorry about the misplacement, but we got there in the end.
Great. Yeah, so the technology is found. So for Internet of Humans, we have HTTP, which works great. For Internet of Things, we have MQTT. And MQTT there really provides a very easy flow. When we go back towards our first example about the remote door unlock, so MQTT, you just send an MQTT message or publish an MQTT message from the smartphone to the MQTT broker, and then the broker will just forward this message to the car to unlock it. And it will, over the publish-subscribe mechanism, know where to publish it, but it will also, of course, have a security set there to make sure it only goes to the car which actually is bound to the user that sent it. But also, of course, now we have talked a lot about MQTT, but MQTT is just a protocol, right? So it's something like HTTP can be used for different kind of scenarios. But what especially makes it suitable in order to bring it into production and to make a reliable and successful connected car platform. This is where HiveMQ comes in. HiveMQ provides this platform where you can easily connect cars over MQTT to it. So HiveMQ is a distributed system that can run basically on any cloud or on-premise system. So that means we have customers using it on bare metal or on virtual machines, but also a lot of on Kubernetes, for example, or OpenShift. Run it more cloud native anywhere to just make it able to scale up and down easily. And then we have native integrations with our plugin system to easily connect to things like databases, sometimes old school databases like Oracle, but also stuff like Apache Kafka, also security services like OAuth servers, but also, of course, IoT platforms. And often than not, it's also the typical services from AWS like Kinesis, or also the Azure Event Hub, Event Bus. So there's a lot of flexibility there, and we provide the first, let's say, connectivity, cloud native connectivity layer for our customers, so they can independently and vendor neutral use MQTT and 100% of MQTT towards in the cloud, and then afterwards just can choose whatever they like with the HiveMQ integration framework. And we want to go now into more detail of some of the aspects that are important and also solving the challenges we outlined in the first part of the presentation. First of all, when talking about scale, I think HiveMQ can scale up to 10 million plus persistent always-on connections. That means it's able to just more than 10 million simultaneously car connections. So therefore, easily all the cars can have an active connection and send messages back and forth in a bi-directional way with a massive scalability there. And it also, of course, you can reconnect. If there is a tunnel or if there is a signal loss, you can easily reconnect, and MQTT is able, or HiveMQ is able to basically start where the connection stopped. So the MQTT broker and the HiveMQ makes sure the persistent connection is stored on itself, and it will then continue on the same stage where it was before. And this is one of the key things in MQTT, that it makes really sure that no message gets left behind and gets really the massive amount of data from all the cars towards the cloud, and then also forwards it further on. And not only the scale is important, but also guaranteeing and reliably delivering data. So I mentioned before this quality of service level. In quality of service, there are two different levels, which makes it possible to kind of prioritize messages. So, for example, for messages that are not so important, you can just use quality of service 0. That means at most, so the message will just be sent once, and if it's received, it will be received, and otherwise there will be no security or no guarantee. For at least once, MQTT guarantees that they are delivered at least once to the recipient or to the broker in this case, and also on the exactly once, they make sure that exactly one thing comes towards the broker. For example, a good example for at least once would be sending, for example, updates regarding location and so on, to make sure that the location, for at most once would be location, because if the car is moving, the next location will be sent a second later. So if one message doesn't arrive, it's not the end of the world. Of course, other things which might not be sent that often. Maybe there's something sent every minute. At least once could be used to make sure this one is there for sure. Exactly once, especially, is used for emergency or security cases where it needs to be cleared only. For example, only unlocking the car once would be ideally the best case. So using this here is a good choice. Also, retained messages help to just always have a value. For example, if a mobile phone or something new comes on, there will be the last stored value available, just to make sure there is always a data point there. So the car or the mobile phone, whoever the recipient is, can kind of immediately get the current status. And of course, as I also mentioned before, the offline queuing. So HiveMQ will queue all the messages that are arrived when a device is offline, or a car was offline, or the mobile phone, and then kind of transmit it later on. So these kind of things, messages get to their rightful recipient without any further configuration or further involvement there. This is, I think, a key piece that the MQTT HiveMQ brings with it. The key features from MQTT, 100% implemented in HiveMQ, and also, of course, bringing the high scalability to 10 million plus devices. We're also testing now even more than 10 million because our current customers are soon reaching double-digit million as well. So another thing is, I mentioned the challenge of scale up and down, but also kind of reducing infrastructure on, let's say, idle periods, or also, of course, if maybe something happening to an underlying VM or something. So HiveMQ is really able to elastically scale and auto-heal itself. So we can elastically add new HiveMQ nodes and scale down, especially when the overall car fleet grows. It's easily possible to add more nodes to the cluster to have a better scalability and a better performance. But also, of course, to make sure the masterless cluster approach, it's very easy to deploy and too easy to maintain, to make sure there is no hassle in kind of setting everything up, making sure this whole HiveMQ cluster looks towards one of the clients as one big cluster. There's really no difference to which of the nodes one client or one car connects, because it feels like the same thing for all of these. Another thing which is very important is the deployment. So we are offering basically deployment of all kind of infrastructure, from bare metal to VMs. We also have a managed service if customers don't want to actually host it by themselves. But currently, on the automotive industry, all of the customers are doing self-hosting, either on a cloud or container-based deployment, or also on the VM or bare metal deployment on their own data center. But everything is possible here, and for us, it's one of the key things to kind of deploy HiveMQ wherever you are with your preferred cloud provider or your preferred containerized system. So we enable all of these kind of things, and also provide containers to easily kind of use it that way. Also, quick interesting fact is, today we have released the new HiveMQ 4.4, which actually ships with a Kubernetes operator to make it even more easier to do auto-scaling on Kubernetes. Coming towards another topic, the integration part. I think also a lot of people said integration is a challenge. So we have open APIs and an extension framework to make it easily possible to integrate HiveMQ, the data that comes in towards other data sources, which they should get the data. And we either have easily plug and play extensions that you can just use and drop into HiveMQ, and then they just work. For example, for Apache Kafka, we have this. We will soon have it for other a few databases. We also have a security extension, and we also released today a bridge extension that makes it possible to bridge between different HiveMQ brokers. Sometimes we see this, especially in smart manufacturing use cases. But also, of course, we want to release more and more analytic based plugins, and also, of course, towards enterprise services that are pretty important to kind of get the data towards there to present them and visualize them for the end user. So our customers are very much appreciating kind of this feature set of this kind of ability, just so that they can extend and use it and implement it in their environment as they like it. And this kind of is really a huge thing for our customers, especially on automotive. We see a lot of companies developing their own security frameworks or security things just to comply with the existing standards and make sure the existing system in their company can easily adapt it here. And then another point, of course, is the observability and the insights for operations. So we have a web UI and control center that really helps, even with 10 million of clients, to search through all the clients to make sure you can see what messages they have sent, to see what kind of subscriptions they have, so what kind of information they want to get from HiveMQ, but also you can see overall health of the system. So is everything running healthy? But you can also let's say manipulate clients, maybe add new clients or even disconnect clients just as a admin and configuration interface for making sure the operations team is happy to know what's going on, and also to kind of easily find out what's going on, find the needle in the haystack if things are going wrong or things are not going as expected. As I said before on the poll, this is something especially our production customers have urged us to kind of extend and provide further functionality here, because when you have 10 million or more devices, it's really hard to kind of know which device is doing what and so on. Great. So summing this up in an overview, so HiveMQ for connected cars, we have the 10 million plus always on client connections, like car connections that are connected at the same time and can get push notifications or push based data, but also send data, of course, at the same time. We're having a guaranteed and reliable data delivery together with that. Of course, also scaling elastically and auto heal at the same time, deploying wherever you like cloud neutral and cloud native deployments. Also having open APIs for custom integrations, but also to enable our enterprise extensions to easily just drop them in and use them without coding or without doing anything else. And of course, observability and insights for operations to know what's going on. We got the feedback multiple times. It's very peaceful and very, let's say, people are getting a peace of mind and they just know everything is working well and they can just access the system and know what really is going on and how they can even fix or debug or let's say trace single clients or kind of messages they're getting back and forth. Very important. So here also one of customers that successfully implemented this for is ECARX in China. They are independently operated by the Geely holding group, and also their key challenge was to manage the connectivity between cars and the cloud. And HiveMQ provided them with the latest MQTT standard. They especially also wanted to use MQTT5. This is the latest standard, which we are one of the only companies that kind of implement this 100% currently, and also at this big scale. And it has really improved their reliability of the whole system there. The extension framework were easy to use for the message flow of the MQTT connections, so get more information there and also pull information out of that. And they connected already 2 million Geely cars with that. They are already in production using it with 2 million cars. And an average of 350,000 connections are simultaneously connected. And they achieved an overall cost reduction based on MQTT and HiveMQ of 30%, which is a big thing for them. And even they are connecting more cars and more things in the future. Also want to not only the Chinese cars, also the ones they ship to Europe or the US, they also want to connect with HiveMQ as well. So the 2 million number will greatly increase over the next couple of months and years. This is one, I think, good example what HiveMQ has enabled, doing them the same similar things we also did for German or US-based companies, like, for example, BMW, Audi, Harman, Autonomic, and others. So in general, to kind of sum it up and come to a conclusion, to leave enough time for also a Q&A, is that HiveMQ is becoming more and more the standard for connected cars. And we expect that in 2022, we have more than 50% of the automotive OEMs are using HiveMQ as their foundation for connecting their cars, either directly by working with them or by working with them over third parties that enable us also to connect their cars or part of their cars that kind of transport data back and forth. So we are already a lot of companies working with HiveMQ already, and of course we onboarding more and more people here because MQTT and HiveMQ is really a battle-tested and sophisticated combination for the automotive industry, which a lot of people enjoy and currently use. So yeah, this was kind of the things I want to talk to you about today. Thank you very much for being part of this webinar, and I'm looking really forward to getting to the Q&A. So we have, I think, 30 minutes time of let's say, answering your questions, and I'm happy to see what kind of things you want to know from me. Thanks so much.
Thank you very much, Christian. And just before we go to the Q&A, I would like to let everybody know that before you log off, if you downloaded the PDF, you might want to refresh the screen because we changed one of the slides in the PDF, and so there'll be an updated PDF. So if you refresh the screen and then download, you'll get the updated PDF. So let me lead with one of the questions. So if you deploy MQT5, what's required to upgrade or transition to future releases of MQT?
So if I'm not sure what if you deploy on MQT5, so I'm not sure what the question means if going from MQT3 to MQT5 or from MQT5 onward. I would interpret to the question like what is necessary from MQTT5 afterwards. So
right.
So what we have seen, if I can only talk about what we have seen now and what the current state is. So MQTT5 is relatively, let's say, young. I think it has been specified finally in like 1.5 years ago, but still it's becoming more and more popular still. So betting on MQTT5 now, I think, is a good way to do. The same thing was for MQTT. The switch from MQTT3 to MQTT5, for example, is very easy with HiveMQ because we support all the protocols. So for example, for us, even MQTT 3.11, even MQTT 3.1 clients can speak with MQTT5 clients. So it's very important here to be aware which kind of software you're using, and make sure that they are compliant over all the versions. Also, the MQTT, the basic packet stays the same, but of course it's a new protocol version. So either you have to implement it or don't implement it. But also the software using kind of helps a lot there to make sure the transition is smooth. And then also it can be very easily done. And of course, all the clients, so on the client side, for the car side, they need to be updated with the next, let's say, software release, software update.
Okay. The next question, I think, is really about the structure. So MQT, the client will be in the device. The MQT broker can be in the cloud or any place on the OEM premises. or in the network. But in what cases would the MQTT broker be in the device? I guess in the car, or would it be? It wouldn't,
Yeah.
I don't think.
But this is an interesting question. Definitely, the MQTT client will be in the device or car. The broker is normally in the cloud or the OEM data center. We're currently also discussing with some of our automotive clients to put the MQTT broker also in the car. This would be like a way to communicate between different ECUs and also make sure this lightweight and easy architecture is also possible in the car. But we are in the there's a lot of work to do this. But if somebody is interested in, let's say, if you go in the car, please feel free to reach out to me after the webinar, and we're happy to share our thoughts. And we're also looking towards implementing something like this in the future, maybe depending on the conversations we're having with people.
So, as a follow-on to that one, this is with edge structures, Christian. Is the concept also that the broker could be at the edge of the network as well?
Yes, definitely. This is why we have now also one thing where we released our bridge extension. So there could be, or that we see this a lot, the broker at the edge of the network, and then another broker on the cloud side. These two brokers communicate and only share a subset of data. So not everything needs to go towards the cloud. So only things that needs to be go there will go there.
And I assume that also reduces some of the latency aspects as well, doesn't it?
Yeah. Yeah. So there's a question about TLS, SSL. I want to just quickly answer this one. So I would like to think about security. Does it provide SSL encryption out of the box? Yes, of course. So HiveMQ provides TLS, SSL encryption out of the box, and with there's even possibilities to only look at certain cipher suites there. And of course, with the plugin, the extension system, there are standard extensions to make very sophisticated security possible. And also, you could implement your own kind of security extension or use your own extension here for some very specific custom use cases.
Okay. Next question is MQTT traffic allowed in all firewall scenarios, e.g. public Wi-Fi, etc., or is MQTT only recommended when there is SIM-based connection to a telecom operator data network?
So for this, most of the use cases we are working with, it's SIM-based. So we see that it's, especially on the connected car side, we don't see this problem with firewalls there because each car has their own SIM card, and it's just like the automotive OEM or supplier or whoever does it has it in their hands. Just make sure that their firewall kind of uses it. I'm not on public firewalls. I have we have not so much experience to be honest. I think it would depend on how these kind of things are configured. There are some workarounds to kind of use MQTT over WebSockets, which then also makes it easily possible to use it over HTTP channels, but still provide all the features for MQTT. So if you are in a public Wi-Fi, I would encourage to not use MQTT over TCP, but using MQTT over WebSockets, which then is easily possible.
Okay. Next question is, how do you integrate HiveMQ broker with Microsoft Azure?
Yeah. So on the one hand, we have a lot of customers that kind of run HiveMQ on Linux server on Azure. So just to deploy it there, we also have a kind of documentation how to do that. And also in the future, we will have more and more tight integrations with Azure for extensions into the different services Azure offers. And also we strive to be in the marketplace, so people can easily just deploy HiveMQ with one click. And currently, you still have to deploy with our kind of step-by-step instructions to bring it there. So, but a lot of things are coming. We see people, especially using a lot of Microsoft Azure these days. So this is one of our targeted things which we want to bring out more integrations and better integrations in the future.
Okay. Question here. Why would I use at least once as opposed to exactly once, even if the message is not security critical, to avoid excessive use of bandwidth at scale? I guess the question is about scale and bandwidth.
So, yeah, so normally we see when bandwidth and scale is a thing, we often see people are using at least once, like quality of service 1, because exactly once requires a lot more bandwidth to enable it. So we see people, so normally for, I would say 90% of the messages, quality of service 1 or 0 is used, and only for very specific cases quality of service 2 is used. So this is the best way to do it. And if kind of duplicate messages could harm the system, just having kind of software or checks in place on the receiver side to make sure this kind of would not result in any bad behavior. But as I say, like in 90% of the cases, quality of service 2 is not actually used.
Okay. Then, do you also provide an easy way for vehicle drivers to consent to sharing driving data with other parties, such as UBI insurance providers?
So this is not actually on us to decide. This depends actually on the OEM or supplier we're working with, because we're just providing the infrastructure in order to make it possible. So we don't have our owners of the data. So we are just enabling the enabling infrastructure below this, so we don't kind of actually have the data in our hands.
Okay. Another one. How does HiveMQ handle bulk data transfer requirements?
Yeah, so the question would be what bulk data means. There are different kind of ways for doing this. It depends on how big it is. So the MQTT is a message-based protocol, so you could split up kind of packages if they are too large. Other ways, we could also send out the HTTP link, so the car or the device can retrieve really large data package over HTTP as well, especially when they go over hundreds of megabytes or gigabytes or whatever, which is sometimes necessary. But there are either it's set to use with HTTP or use split up packages for multiple MQTT messages.
Okay. I guess this is similar but different. How can you reduce latency without burdening the network with excessive pings, and thus reducing the efficiency of the network by being always connected?
Yeah. So, of course, in order to always connected comes with one of the parts is the ping. So so the ping is make sure that both sides, like the car and the HiveMQ broker, still know that both sides are connected. And depending on the network, the ping can be vary. So MQTT allows this from having this only for each second up to, I think, a couple of minutes even. So it depends on when you are aware or know that the network is strong anyhow, the client could easily reduce, or let's say longer, make the ping time longer. This then enables also to have less pings available there. So it's totally this based on the car can even decide on this on their own, and depending on what kind of normal scenarios would be, and depending on the exact use case, we've experimented this or found out with customers, depending on their use case, what the best, let's say, trade-off is. This is always a trade-off. So on the one hand, if you do more pings, you have an accurate status, and if you do longer pings, devices could already be offline you wanted to send messages to. So of course, this is like a trade-off, but I think with the ability to just kind of, the client can just set his own ping, this enables devices just to choose whatever they are, makes sense for them, depending on, for example, where they are in the city or in the countryside and so on.
Okay. Well, with that, Christian, you've taken us up to the top of the hour. Thank you for being so open and direct with the answers. Good selection of questions. So to our audience, thank you for joining us today. I hope you've found the webinar interesting and useful. And we look forward to welcoming you back again in the near future. And once again, thank you to you. And Christian, thank you for your time and your knowledge and experience that you shared today.